So I saw videos and they, instead of like writing the whole configuration, they would write like argon.
I won't let you do it.
Oh, like
It's called the shortcut.
Yeah.
Why would I let you do a shortcut unless you know? He doesn't even know how to do the whole thing,
I
right?
understand I understand why the shortcut's there, but I'm just
No, you don't.
confused on why the P starts at 2 but not 1.
Because one can only have an
One
S.
can only have
Energy
S.
level.
Yeah. Oh,
What? Oh, I thought you were telling me.
like I know I can write the numbers down, but I was just kind of confused on the placement of the numbers.
Placement of the what?
Like I was just confused on why some of them started with that number rather than
What number?
like why P started
Come
with
up
2.
here and touch something. Show me something.
Like I know like
Come up here.
hey,
It's 3D10.
like how's
The formula 3D10.
Y D would
10.
start with 3 and P would start with 2.
Then
Like
4
I get it now that
P6.
you said this. Like I know how to do this. But I was confused on
4
why.
P6.
This is the first thing I taught you.
Yeah, I know, but
Yeah,
it was
then
just
4
kinda
P6.
How do you think of it? I didn't understand.
4 P6.
I told you where all these things start, right?
Yes. You did. I just, it wasn't, I kind of forgot.
4 P6. 5S2.
And there's always room for you when you start right there.
Just 5. Just
Yeah. What? Then go underneath.
5.
I understand the abbreviation.
5S2.
Because these are all completed, right? To the end.
Can you do this? That means no.
And then 4D7, I think.
No. Either you can or you can't.
It's 7.
I'm just telling you.
Yes.
Either you can or you can't. What?
Do we use the, what are these called again? The gases? No, the noble gases because the valence shell is always full for each of them. So
Do
you can
we
just,
use the noble gas?
like when we do the shortcut method.
Who's doing the shortcut method?
Well, if we were.
Not a thing. I didn't teach it. I'm not gonna allow it.
Okay.
All right?
Yes.
Don't play games. Shortcuts are when you know things. And what am I trying to teach you?
How to-
How to know it.
How to know things. All right? And people are having trouble. There are people in here who can't do a full one. So I won't allow it. Is that clear?
Yes.
All right? Same thing with your math and your calculators. You guys know how to do stuff on your calculators, but you don't understand how it really works. I won't allow it. You got to know your stuff. Do you understand me?
Yes.
After you know your stuff, then you take the shortcuts. It's the way life works. Okay? Agreed?
Yeah.
Yes. How many valence does it have?
2.
Why? What's the definition of valence? What's the outermost shell here?
5S2.
5. Isn't that the highest energy level?
Yes.
And how many electrons are in the 5th energy level?
2.
There you go. Yeah.
I don't understand why 5S2 is the most outer.
What's bigger? 5, 4, 3, 2, or 1?
5, but isn't the 4D doesn't that have more like energy?
It has a little more energy, but which energy level is it in?
4?
And what's the definition of valence?
The outer most,
What's the outermost energy level?
I guess it would be
You
5.
guess.
I mean it's 5.
You have to guess?
No, it's 5.
It is. So how many electrons in the 5th energy level?
2.
That's the definition. I'm not talking about energy. The definition for valence isn't the electrons with the most energy. What's the definition of valence?
Most outer shell.
The electrons in the outermost energy level. Do you hear what I'm saying? All right? Definitions are important. All right? What I taught you yesterday was kind of like a trick. But if you don't understand what it really means, you're in trouble. Do you understand me?
Yes.
Do you understand things, or do you look for tricks? Do you look for shortcuts all day long? I'm asking you to understand it. Okay? It's not a bad thing, people. Right? So try any other one and see if it works. Pick another one. Copper is going to be in the same place. Copper is going to look exactly the same.
Aluminum
Anything in the middle,
is the same.
anything in the middle, any D has what valence?
2.
2. Any F has what valence?
2.
2. So why don't you pick something else?
Aluminum.
Never mind.
Did you actually say
I don't know if you understand what I'm saying. Uranium is in the F's.
Silicon.
Those are also.
Go ahead, do bismuth.
Oh my god, I understand.
There you go. Yeah.
Yay. It feels nice to understand.
Bismuth. Go ahead.
Business.
How many valence? Why?
Because of
Count across.
success.
Yeah, that's your trick. Why is it 5? I know you guys so well. You know your little tricks and they work, but you don't know why. Because I'm going to ask a question and I'll mess up your trick. Watch me.
I have seen
I'm
it.
gonna hear you.
You're going to be mad at yourself. Huey, why did I screw this up? Because you're using tricks without understanding. Why is bismuth 5? I want someone to explain it to me. Anissa.
The outermost energy levels are 6s2 and 6p3, and then you just add the amount of electrons.
Correct. He wasn't paying attention to you because he didn't think you were going to be right.
If you were to write the configuration, the outermost energy levels would be 6s2 and 6p3, and then you just add the 2 and the 3.
Correct. Did you hear that now? That's what valence means. All right? You want to keep on using tricks? Go ahead. It'll get you by most of the time. All right? Anybody else have a question with that? No? Starting from when? Good morning, everybody. The beginning? My name is Mr. Huey. The biggest problem with this class is that I know you. What do you want to know? What do you want to know? For who? For what? Go ahead, give me electron configuration. Go. Go. Hurry.
1 is 2, 2 is 2, 2p6, 3 is 2, 3p6, 4 is 2, 3, 10, 4p6, 5 is 2, 40, 10, 5p6, 6 f 2, 4 f 14.
I know you didn't finish it. I'm waiting for you to finish it. What comes after 4F?
5 and 10,
And then
6,
6 what?
63,
What's the highest energy level?
6.
6. Add up all the electrons in 6. Go.
Oh, 5.
Correct.
Wait, what? Yeah, 3 electrons. 6p.
The 3 and the P and the 2 is S.
Wait.
Oh.
Oh!
Yes. In that level.
Wow.
6 is on the side, 6S and 6P.
That's quite beautiful.
Oh, yeah, it is. I know, and I taught it. I just taught it like 3 times this morning.
How did you understand like the YouTube, or did you just notice the pattern?
I watched the video and then I just noticed the pattern. Like, they did the same reasoning for here, so then I just did it for everything else.
Do you get it now?
Yes, sure. Can we do some more? This is kind of fun now.
No, because once you know it, you know it. Then you're just wasting time doing things over and over again. How about we learn something new?
I agree.
Right? You only have one period with me
arrows?
today. What?
Are we going to do the thing with the rotation of the electron?
The what?
Where you do the, like, Like,
What's he saying to
the
me?
box with the arrows. Doesn't that talk about the rotation of the electrons or something? Right?
About spin.
Spin. Sorry, that's the word that I meant. Exactly. I'm not very good with my words.
You don't read.
I do read. I kind of learned this over the summer, kind of.
Okay, you guys, tell me what you want me to go over then.
Box diagram.
I have a quick.
Hey,
1 second. Sorry. It's sorry. 1 second. It talked about base. It's a base. Base.
okay, stop talking.
Wait.
Just look at what you're trying to figure out and ask me.
I lost my page. This is stressful.
Stop talking.
Ground state energy. So what exactly, like, it would talk about hydrogen and how it can go like above the, like when you excite it, it would go above the first shell. But I thought hydrogen would only have one shell, so it couldn't go above that.
Oh, that's a good question because that is so wrong. Ready? I have an apartment building.
Okay.
I only have people living on the first and second floor.
Okay.
And if I excite them, say there's a fire, yeah?
Uh-huh.
Where do they go?
On the side. Oh yeah.
No, on the first floor, second floor. I forget.
Yeah.
They go up.
Where are they gonna go?
We can-
Up to where? Fine.
Higher.
Third floor. Next. After that, fourth floor. Yeah, but no one's living up there.
But I didn't know there was more floors.
Well, what's my point?
I should know there
Just
was more
because,
floors.
no.
There's an infinite.
Just because there's nobody up there doesn't mean there's nothing up there.
Okay.
Just because hydrogen only has one electron, one energy level in the first energy level,
Mhm.
doesn't mean the second, third, fourth, fifth doesn't exist.
Right.
Where else would it jump to?
Right.
They're there.
Mhm.
There's just nothing in it.
Mhm. So then, since you're talking about the floors, if you like look at the floors, and this has like the discrete energy levels, would each floor be like a different like? They
Distance.
could only aim like right?
Number of stairs.
Yeah. Okay.
All right, that's a quantum. That's why quantum is not a specific number.
Mhm.
It's just what's the energy that separates.
What if like a atom gets excited by like a certain amount
An
of energy,
atom, yeah, go ahead.
gets excited by a certain amount of energy that's not enough to bring it up, but
It won't go up.
Okay. What happens to the energy just like move on?
It's not absorbed.
Okay.
So I was trying to tell you, it has to absorb that exact amount of energy to jump,
Mhm.
whether it be 1, 2, 3 floors, whatever.
Yeah.
But if it's not that amount of energy, it won't absorb it,
Okay. Got it. Thank you.
and therefore it won't release it either. Okay?
For Bohr's model,
Bohr's model. Yep. Niels Bohr.
right? What exactly was wrong with it? I was going to.
Yeah, remember I talked about orbits versus orbitals. Do you? You can be honest with me, even though you're all burnt up, like a little
Is that
It's gonna roast
Oh,
you
what?
again.
all burnt up, like a little chip.
that's a good one?
Orbit. What's the difference between orbits and
Go with
orbitals?
the cracker.
I did not say that. Don't put words in my mouth. Yeah.
Orbits, you can know the placement and the
Velocity.
velocity, but orbitals you just know either or.
Either or more so, what model are we using? What's this called? It's called the quantum mechanical model. And we talk in probability densities. Meaning there's a probability there's an electron in the moving around in this sublevel, this shape. Okay? Orbits, like we talked about the sun, us going around the sun, we know exactly where everything's going to be and when. Electrons don't work like that. That's why he's wrong. He thought that electrons
They're exactly in the same path.
go into an orbit. Which, if you take a look at the natural world, makes sense. But it's not true. Nobody wants to flip through and ask me anything? There's nothing you need to know here?
I kind of have a question about those electrons and how ions work. Let's
Yep.
say iron.
Iron, yep. Which one? Which iron?
Three.
Iron 3, yep.
Where are the electrons for that being lost?
Very good. You guys understand the box and arrow diagram?
Yes.
Do you?
Yes. I think.
Those of you, I'm just gonna throw this out there to improve you as students. Those of you who don't know what to ask or don't care about what's being asked, you're not being proactive about your education. All right, you expect me to explain everything to you eventually. This does not work in college. Do you hear me?
Yes.
All right? If you're just sitting there, I'll let them ask, blah, blah, blah. Maybe everyone understands stuff and you're the one that doesn't understand something and you won't ask it. You're gonna lose in college. Do you hear me?
Yes.
And I can tell who's not trying. I just know. All right? So, just be careful. Give me electron configuration for iron.
1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6.
All right? Now, we can show this also with something called box and arrow diagrams. And I'm going to go up showing energy. So 1s, 2s, 2p, 3s, 3p. I'm running out of room. And then 3d. It's a little bit higher. 4s, 3d. Okay, so these are the S's over here. And again, as I go up, it's higher. The book doesn't do it this way. I do it to show energy. Okay? 1s, 2s, 2p, 3s, 3p, 3d, 4s. Okay? I'm going to put the electrons in. All right? Electrons are shown by arrows. Arrows that spin up and down. And you can ask me that at some point. But only 2 electrons per orbital. That's called the Pauli exclusion principle. Only if they spin in opposite directions. That's the rule. All right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Agreed?
Yes.
Wait, so like, why can't you do like for 3D? You know how like there's small hair on these rocks, right?
Why don't we squish them in?
Yeah.
Yeah.
You can ask me that in a second. That's the next question, okay? But that's the way it looks, all right? Now, what's the valence for iron?
2.
2. And if electrons are being lost, guess where they get lost from? The valence. Ferrous. Iron 2. Understand?
Mm-hmm.
But look at here. Do you see something that's a little bit not, how do you say, balanced or not symmetrical in what's left?
All the spins except for 2D are up down. But we've got all
There's something else that's a little bit more glaring. That's just not symmetrical. Say it. It's okay.
I don't know what it's called. That 3D thing.
What about it?
There's no.
Are you talking to me?
I don't know how you explain it.
There's no other arrows pointing down. Is what she's trying to say.
Just let up even.
Meaning, this is weird.
Yeah.
Not symmetrical. Huh.
Does it work?
Symmetrical?
Yeah.
Yes.
Ferric. Okay. I just took away 3 electrons.
Oh.
Ferric. I just showed you where they came from. Which was your question? Why? The symmetry. Okay? Has to do with this. Full sublevels are stable. Understand? Full is good. Understand?
Mm-hmm.
You guys ever collect anything?
Yes.
What?
Bad grades.
Yeah. Do you have a whole set of those?
Yeah.
What do you collect?
Stickers.
Stickers, Pokemon cards. All right. Do you know
Coins.
coins? I used to collect those state quarters with my kids,
Yeah, me and my dad did that.
right?
Like
Yeah.
coins.
But you know what? For some reason, we're always missing Arkansas.
I've never seen it.
I know. I don't even know where. Is that a state? Okay, now. Isn't a full set more valuable than a broken set?
Yes.
Yeah, think about it that way. All right. But in the world of electrons, the next best thing to full sets is a half set. The next best thing to a full set is a half set. Full, half full. Half full is okay. It's symmetrical. Do you understand what I'm saying? So things gain or lose electrons to become full sets or half sets. Or electrons actually will move around to get full sets or half sets. All right? The word for this is called pseudo-stability. Pseudo-stability. All right? You guys know this word?
Yeah.
What's this?
Yeah.
All right? It's fake stable. Real stable is full. All right? But half full is pseudo stable. Just like from pseudonym, right? Okay? You may. All right?
So what the heck's wrong with manganese then?
I don't know what the heck is wrong with manganese.
Because it has 2, manganese 2, manganese 3, manganese 4, manganese 6, manganese 7.
So nothing's wrong with it. It has the ability to lose different levels of electrons to become different levels of pseudo-stability. Let's do one for you. Everybody, chromium. What's the electron configuration? Chromium. Come on. Yep. 3D4. It looks like this, right? Everybody look up here. Chromium, yes?
Mm-hmm.
Huh. In reality, if you check your periodic table, that's not true. This is what I taught you. It should be 3D4, but it's not. You know what really happens?
It's 3D5 force one. It's both half.
What did I just teach you? What did I just teach you? Pseudo-stability. This half set makes that electron to jump up here, makes it more stable. The number of electrons doesn't change. It's just where it is. In reality, an electron from here will be up here to make these half sets, perfect half sets, which is better than a messed up set. Do you understand me? I'm not telling you for you to predict when pseudo-stability happens. I am telling you so that when you see something that doesn't quite fit right, you say, oh, that must happen to be more stable, pseudo-stability.
For ferric, how did removing the electrons from 4s make it more stable?
Valence first. The easiest electrons to remove first are the outermost. and there are 2 of them there.
Oh,
All right?
Since it's not full, it would make it more stable to remove them. Like, I don't understand if the
No. That doesn't have to do with pseudostability at all. The third one had to do with pseudostability. The first 2 just had to do with, they were the outermost electrons. Remember, what do electrons, if I'm going to remove electrons, am I going to remove the ones closest to the nucleus or farthest away? And what are the farthest away ones in iron? The 4s2. They go first. All right? And when they go, guess what? The 3s and 3p are full, which is kind of good. Right? It's the next level down. Remember, 4s is not a full valence. Understand?
Yeah.
But 3s and 3p full is kind of a good deal. All right? So that's why the 4s goes first. But then if you're going to lose another one, it makes sense. It doesn't want that last electron to mess up the half Ds. So you get ferrous and ferric, and those are the 2 stable ions of iron. Okay? Like I said, I don't teach pseudostability for you to go, okay, that must be pseudostable, this must happen. No. No. What happens is what happens. Take a look. You know the electron configurations of all this stuff. It's when something happens out of normal electron configurations, you can say, that must happen because of pseudostability.
I get what you're saying about how half stable is better, but wouldn't removing an electron from the valence shell make it like more unstable, because then like if you're removing something from 4s, why wouldn't that make it less stable?
Why would it? 4s is not a full valence.
Or even
4s2 is not full.
Yeah.
You need 4p6 to get full.
Yeah.
So 4s2 is nothing. It's not really stable.
So doing that wouldn't really affect it that much?
Doing what?
Like removing an electron?
I don't know what you're saying now.
Okay.
4s2 is not stable. It doesn't like 4s2. What did I teach you about noble gas configuration?
The valence shell is always full.
That's stable. 4s2 is not stable. It's not noble gas configuration. Okay? Every atom is trying to get the same electron configuration as a noble gas or pseudostability. Remember I told you the first thing I said about this chapter? We know how to do chemical reactions. The next couple of chapters is why. This is all about why. All right? It's all about the electrons. It's not about the nucleus. It's all about the electrons. Okay? Yeah?
I have 2 questions.
Yeah?
When you lose an electron off of the valence shell to achieve pseudostability, is light released?
No.
Because the
It's
electron-
not dropping down. It's gone.
Okay. And my second question is that why do when you place electrons in the box first, why do they always have to have the upspin first?
Oh. So, how much time do I have?
15 minutes maybe?
Wow. I can't teach it. There are 3 rules that govern how electrons go into these orbitals. The first one, I already told you. You don't remember it. You probably didn't write it down. First rule is called the Aufbau principle.
Oh yeah.
Remember that? It says that electrons go in the lowest energy level first. They want to stay low energy. That's the rule. Okay? The second rule is called the Pauli exclusion principle. Okay? And that just means this. Only 2 electrons can be in an orbital. All right? We already know that, right? But you don't know why. Electrons have what charge? Pay attention to the logic here. Electrons have what charge? Wrong. Dakota. See what this means? Yes. Okay? I'm trying to teach you guys to be good, not just get by. Alright? Electrons are negative. So, why would two negative electrons want to be close to each other? They don't. They don't. So, how do I get two electrons in an orbital? It has something to do with this.
Do you place them opposites?
They're not opposites, they're electrons.
They are on opposite sides of the orbital.
Nope, not necessarily.
These opposite directions.
It has to do with this. Anyone like to go camping or mountaineering? Anyone know how to use a compass?
No.
Okay, what does a compass point to?
The north.
Why?
Because of electron. Oh, when they spin, they
Electromagnetic field is something called a magnetic north. What? It's not true north. True north is pointing straight towards Santa Claus. All right? Santa Claus is Chinese.
Santa Claus isn't real.
Watch down.
It's Mrs. Claus.
Yeah, she's white, but watch down going ho ho ho. Yeah, which is Chinese. You don't understand that, but.
What does that mean?
All right. Why do we have a magnetic north? Does anyone know why we have one? What do you mean, cause the Earth axis? It's not. That's true north. Where's the magnetic? Why do we have a magnetic north? True, that is true, but why do we have one? Why do we have a magnetic north?
Is it because of the direction the Earth spins?
Partially, but what is the Earth spinning? Is that why?
It's how the iron core or metal core of the Earth spins. That creates a magnetic field.
That is correct. You know that?
I was going to talk about this again.
What's in the core of the Earth?
Iron. Melted iron.
It's mostly iron and something else.
Nickel.
Nickel, which are both magnetic materials. And what phase? Wrong.
It's liquid.
It's liquid. It's molten. All right, it's molten. It's so hot. The Earth's core is molten.
That's how we get volcanoes.
No, the crust actually floats on. The crust actually floats on a molten core. Yeah, the outer core, which is still pretty. It's molten, right? Yeah, which is melted, right?
Those candies. You know, I don't know what it is. Those gold candies, the
Ferrero Rocher?
Yeah.
Never heard of it.
Or Rolos.
Rolos? Liquid on the inside.
You like that? You must like lava cakes.
Oh, they're
Never had
Chocolate lava cake.
They're so good.
Like you open it and chocolate oozes out. Never heard of those either. It's because the metal inside is magnetic, but when you spin something magnetic, it creates a magnetic field. If you learned anything in physics.
Yes.
All right? When you spin it one way, you get a north and a south. You can think of positive and negative, right? You get north one way and south the other. When you spin the other way, guess what? It flips. Okay? So, you can think of an electron, even though it's fully negative, if it spins one way, you get a positive and a negative like this. Understand? And if another electron spinning the same way wants to get close to it, what'll happen? Yeah, it won't stay together.
But if the electron was spinning the other way,
They just hit each other.
Ah! It'll stay together. It won't stick together, but at least it'll stay together in the same orbital. All right? Do you hear what I'm saying? And therefore, and third electron, which way will this have to spin to stay with these two? No, but then it'll repel the first one.
That's why there's only 2 electrons in each orbital.
Correct.
What do you say?
A third one won't go in. There's no spin that'll make it stay.
So then how do you...
All right? So that's why all these electrons have to spin up and down if they're going to stay together in an orbital. Okay? This is called the Pauli exclusion principle. Only 2 electrons in an orbital, only if they have opposite spin. Everybody with me?
Yes.
All right? The third rule is the fun part. All right? It's called Hund's rule. Hund's rule. All right? Hund is the German word for dog, which has nothing to do with this lesson. Okay, das Hund. All right? When you guys go to college, freshmen, you guys are going to be living in dorms with communal bathrooms.
No.
Probably. Freshman bathrooms?
Disgusting.
Okay, it is disgusting. All right? And there's a really good chance you're going to have showers that have multiple shower heads. And you just have to go take a shower. And there's a good chance that you're going to have to take chemistry at 8 in the morning. And everyone has to wake up early and go take a shower and get to chemistry in time.
Unless you showered the night before.
Unless you shower the night before. All right? But most people are too busy partying, drinking, throwing up the night before. So you got to do it in the morning. All right? So, who's an early riser? Wow, all these early risers.
We do start school at 7:20.
Okay? So, Andrew wakes up and says, I got to get to chem class because I didn't get Chem AP credit. And he gets in here and he starts taking his little shower. It just so happens that these showers have 2 shower heads.
In the same shower.
Absolutely.
That's luxury.
Okay? And then,
Gio walks in.
who walks in next?
Gio.
In the shower?
Gio walks in.
No.
All right, Gio walks in and goes, man, I got to take chem too. Move over, Andrew. What are you going to say, Andrew?
He doesn't say move.
Get out.
What are you going to say? Why? Give me a reason. Shh. Give me a reason.
I like my privacy.
There's another reason. There's another reason.
I want more water.
There's another reason.
He's a guy.
There's other shower heads.
Oh, we know he's a guy. Huh?
There's other shower heads.
Say it.
There's other shower
Yeah, there's another shower head right there. What do you really want to say?
There's a shower. It's all the way over there.
There's a whole empty shower next door.
Oh, like when you guys use the urinals.
Yeah.
No, even if they're all packed up, we don't say move over. No, you don't understand etiquette. Yeah, we'll all pee in there. No.
No, like you're like, oh, why are you next to me when there's all these other ones?
So, Andrew says, hey, next door, empty. Don't come shower with me. So Gio gets in here.
You have to make it tall.
It's the shower dog.
Why are you just angry like that?
Okay?
Gio doesn't have a waist. Disconnected from his legs.
All right, and then who wakes up next?
Dakota.
Huh?
Dakota.
Who wakes up next?
Sebastian.
Sure, Sebastian.
Sebastian. Sebastian says, Andrew, move over.
Go to the next one.
He goes to you. Move over.
Go to the next
No.
one. Gio's on good head.
Okay? What are you going to say? There's an empty one. Get away from me. All right? So, Sebastian goes over here.
Make him like this.
No, he's super short.
He's not as tall.
Andrew's the shortest one.
What?
Huh?
According
He
to
gets eyebrows?
No, actually, your face is more like this.
You see those
Phineas?
What is it called? The fruit show with the
Dang, why you?
Okay?
You look like the cinnamon stick. The Jamaican cinnamon stick.
He's drooling. He's drooling. Okay? See, what's really interesting, you guys understand this, all right?
Yes.
Who's getting up next? Gabe. Okay, Gabe gets up next, and then he goes to Andrew. Move over.
So all of y'all
Now what do you have to say? Fine. See, you have to. Understand? And Gabe goes in here, and he's showering.
Why does it look
Okay.
like
You're a wizard, Harry.
All right? And then who wakes up next?
Dakota.
Dakota.
No.
Dakota wakes up next. Move over.
Dakota's stoned when he wakes up. He's like, oh shit. Actually,
He's stoned with a rock.
how little hot water he uses, so it'd probably be better.
Okay, translation, get on in here, big guy. All right.
Everyone's short.
And you have your cell phone.
And the jewel.
Okay? And then finally, who is
Shouldn't you drop
that?
the upside down?
Danny.
Danny.
It was 10 cuts.
Sebastian, move over.
Make him super.
Sure.
Sure. Okay, so Danny.
They're gonna be
gets-
big switch.
All right.
Give him a cat.
One shower for one.
Give him a cat.
Yeah.
Where's his cat?
Draw a cat. What is it?
Looks like it's the girl from
No, John like 5 of them.
Oh my god.
Danny brings the cat to the shower.
He gave me the body. All right. Now, hey, Hansrul, what did I just teach you? What did I just teach you?
Stability.
If they don't have to pair, they'll just stick with
They won't pair unless they have to.
Well, okay, Gabe, for example, like for the first one, why does Gabe have to go into Andrew? Why can't he go into no?
He can. In reality, they're all the same. Any orbital is the same energy. I don't care which one you really go into.
That's just better.
But they're not going to double up till when?
They have
They have to.
There you go, Hansrul. You hear me? All right?